Welcome back, students, to the video for Lab 1. Now, if you recall from the intro slide, I introduced you guys to the basic concepts of R, and we'll explore that a little bit more, but we obviously want to get to the the data aspect of RStudio as well, because of course, the whole point is analytics of different data sets. And in this class, I have a whole bunch of pretty much fake data sets that we get to play with. The reason why they're fake is because they're small, more concise, and they give me the results I'm looking for, so that I can push through the points that I'm trying to make in this class. So today we want to focus on extracting, transforming, and loading of data, right? Pretty much. So we'll be using a CSV file. What is a CSV file, guys? It's a comma delimited file or a comma separated file. You guys see this all the time. You guys deal with this. It's basically files where the data is separated by commas. Sometimes you don't notice you're working with it because when especially in a PC, when you double click a CSV file or you open one, it opens in Excel. And even though it's in Excel, it's not necessarily an Excel workbook. It's really a CSV file. So for the semester, we'll be dealing with CSV files. You can deal with Excel files as well, but I show you there's a difference, right? There's a slight difference. So we focus on CSV files. You can read in CSV files, do what you want to do, and export CSV files as well. So a lot of flexibility there when you're working with R. So we're going to start with my text file that I posted, the chapter 1_bike sharing data.csv. Right, so I'm going to show you how we can import it into RStudio, and I'm going to introduce you to the concept of, introduce you to the data container, data tables. Now, I already showed you guys the data table, the basic data containers, which are vectors, and I also showed you guys the data containers of lists that are basically data containers of data containers. Now I'm going to show you data tables, and data tables are essentially the table abstraction in RStudio, in R. So it's basically, if you had like an Excel sheet, right? How would you work with like an Excel sheet in R? Pretty much a table. And so that's what data.table is. Now data.table is what we call a third-party package. It's something that we have to download into RStudio because it's not natively built in RStudio. Another entity or organization developed data tables. And the reason they did that, I mentioned this before, data tables are they're the R's answer or R's version of Python pandas tables. Pandas tables are incredibly fast and powerful. They do take up a lot of memory, just like data tables. Both take up an incredible amount of memory. For any of you guys at work, there are some firms that don't use, they work with Python, but they don't use pandas tables because it's such a memory hog. Same thing with data tables, but a lot of times those are more on the programming side versus the analysis analytics side, right? On the analysis analytics side, you pretty much tell IT, hey, this is the freaking memory I need, and they basically just give it to you. So we'll be using data tables. I'll be showing you guys how to use this particular data container, and I'll show you how to manipulate. Well, I'll introduce you to the concepts of manipulating data in data table. All right, so first things first, guys. If you from Canvas, please download the bike sharing, data.csv file. Right, download it to your class folder. Hopefully you have a class folder by now. If you don't, please create one. And the first thing I'm going to do, guys, here in my RStudio is, here's my RStudio from before. Let me clear everything out. All right, start from scratch there. All right. So everything's nice and new. And what I'm going to do is I'm going to, like before I did with my introduction, I'm going to create a new script file. Please do your programming in your script file. Don't do it in console. You're going to drive yourself crazy. And you will drive me crazy when I try to fix your code. All right, so I'm going to go ahead, save this. I will call it Lab 1. And load this bad boy into my class file, my folder for this class. Let's see, ABI. And here we go, lab 1. Right, lab underscore 1, notice the capital R extension. All right, now from here, I will go in and import my data set. Now I have this data set preloaded, so I'm gonna go ahead and install it, and this is how we do it. All right, to your top right window, you have 3 tabs again. Your first tab is called environment, right? Just like in your introduction, the first tab is where that shows all the data containers, where all the data containers are, and roughly what's in them. Right below environment, the word environment, you'll see a couple of these symbols. One of them being import dataset. See that right there? Import dataset. I will click on that. And now what I basically want to do is I want to do from text. You can choose either or. I'll just choose the first one, base. Doesn't matter. All right, so now this little window pops up. And what I want to do is I want to go to where my data is. Here we go. And there's the data that I want. I click on open, and this window pops up. All right, this window pops up. Now, a couple things. Up here, under name, is the original name of the file. This, whatever, you'll notice that if you put your cursor in here, you can change this. All right. This is going to be this is going to end up being the table's name in RStudio. Okay, in R. This will become the data container's name or the table's name. You can change it or you can leave the original name. I'll leave the original just so you guys can follow along with me. You'll notice heading has been clicked yes because yes, it does have column names. And it has a couple options here for comma. Notice you have a couple of different, you can have different delimiters of files, white space, comma, semicolon, tab. Unfortunately, they don't have the pipe delimiter, which is one of the most popular ones. But there's separate packages that allow you to do that. That's not a problem. Now look down here. You're going to see this. It's checked like this: strings as factors. Right? What does this mean? What does it do? We will get to that. For now, right? Unclick this. Unclick this strings as factors. Right? Uncheck it. And everything else is fine. And you'll notice this is the input file. Again, it's comma delimited, so you can see that clearly here. And you can see how it's going to output right here into a data frame. All right, boom. Scroll all the way down, click on import, bam. All right, that's how easy it was. This is now a data frame. Notice on your top right window, you can click on the arrow. It'll show you all the columns there. It'll show you the columns with the different data types, right? Data types, okay? And it has like the breakdown roughly of the number of rows. Just observations basically means how many rows there are. So there's 7,379 rows. And if I expand this window over here, it says of 12 variables. What does 12 variables mean? It basically means the columns. There's 12 columns, 17,379 rows. All right, easy peasy. And the name of the table is this, Chapter 1 Bike Share. You'll notice it's automatically opened up for you guys to view. Right, I can scroll down, right, etc., etc. And if you by chance close this, if you put your X over here, close the sheet and you want to open it up again, just simply go back here to the top right window, right? You click on it and your table pops up again. It's that easy. All right, so from this point now, okay, took care of all this. We're at this point now, all right? By the way, I wanted to point out also, when you click on this box anywhere around here and launch this, you'll see the code down here, right? So this is the code to actually do it. If whatever table you have in here, if you just type in the function VIEW, parentheses, and then whatever the name of the table is, it'll launch. So you can do it from either the command prompt down here in the console, or you can just click on it up there. All right, now what I want to do is I want to also point out the other function, the read.csv function. I already took to the view function. All right, when we read in, this is the command right here. When we clicked on import dataset and put in the CSV, click the CSV file, etc., etc. These are the functions that were called to do it, right? This is basically the one-line function that called and did it. You'll notice that I have an Apple, so it's giving me the class path according to the Apple syntax. If you have a PC, it's going to give it to you according to the PC syntax. And it basically found the file according to your root folder in the computer, and it loaded up into this particular table name. All right. Now notice that instead of an equals, they have an arrow minus like this. And you'll see this from time to time. Instead of, I might as well knock this out. Instead of something like this, you'll see something like this. All right. Right. You'll see this on the internet a lot. This notation is from, I believe it's from Fortran, if I'm to be correct. I never programmed in Fortran, but they basically mean the same thing, right? They are in 99% of the situations, they're the same thing. 99% of the situations. There's like a 1% situation, off the top of my head, I can't remember, where the arrow, you do need to do the arrow dash. I don't think, nothing related to this class, all right? Nothing related to this class. So the single equals is the one I use because it's one keystroke versus two keystrokes. So that's basically what's going on down here, right? It's basically the equivalent of saying equals, if you will. So that's basically what's happening. Even when you type in these other URL, when you use RStudio's cool little widgets over here, the commands will be sent down here, the equivalent commands, and you can see those commands being called. All right? All right, now, in addition to this, ladies and gentlemen, I'm going to show you the difference between reading in a CSV file and reading an actual Excel file. And the reason I'm doing this, I mean, you guys can do this on your own. I won't do it here. But in Canvas, I also loaded up the bike.xls file. And what happens is that a couple things happen. Automatically, when you use this feature, this command library.readExcel happens, and this read_Excel happens, right? And essentially what's happening there is, actually, let me go ahead and do that for you guys. So let's go do import dataset. Right, this pops up, and I'm going to go ahead and read in the Excel sheet, right? Notice completely different setup, guys, completely different setup, right? The name, you see this code preview. What's this library command means? This part, you've seen something similar with the read SV. This capital VU, you've seen that before. What does the library mean? I'll get to that in a second. So I run this, and you'll see this comes up, right? So now I have two tables, right? I have two tables. Chapter 1_bike and chapter _bike share _ sharing _ data. All right, looks virtually the same. Looks virtually the same. Several differences, right? Firstly, this date time. It's a different format than this date time. All right, we'll talk about that a little bit later. But what essentially happened here? All right. Firstly, what is this library.readExcel? What's going on there? Library.readExcel, what that does is it automatically calls you guessed it, a library that's not preloaded in R. So if I turn your attention down here to the bottom right window, you'll see 5 tabs: Files, Plots, Packages, Help, and View. Under Packages, you'll notice something called System Library, right? And let me scroll over so you get a better name of it, all right? And you see all these names, and some of these names are checked, and a lot of these names are not, right? What's going on here? This is a list of all the libraries that are preloaded in R when we downloaded it, right? And even though it's preloaded and it's here, it's not checked. All of them aren't checked off. Why? In R, just like every other programming language, you have tons of different libraries available to you. These are libraries that are pre-written code and programs that you can use to make your life so much easier. All right. Now, why, even though they're all, there's a whole bunch preloaded, why are only certain amounts checked off? All right. Why are only a certain checked off? It is because we only use the libraries that we are going to. We only check off, or let's put it this way: anything that's checked off is loaded into your memory. Okay, when we launch our studio. Okay, so why aren't all checked off? Because if we checked off all the libraries, all the ones available to R, even the ones that are preloaded, your memory would come down to a halt. Your computer would barely stop running because all of these packages and libraries are preloaded into memory. That's why we only check off the ones we're going to use, because we want to leave space open in our memory. That's the only reason we have this system. That's the only reason. This is not just R, this is all programming systems. You never call all the libraries available to you because there are hundreds of massive libraries available to you, right? Especially in R, because R is what we call freeware, and you have, institutions around the world building libraries and programs for R for everybody to use, right? So there's no way you're going to preload all that stuff, right? I mean, your computer's not going to work. So we only check off or use the libraries that we need, that are going to be loaded into our memory. That is what library command does. The library command grabs a package, all right? That's a third-party package. It might be in here. It might not be in here. Maybe we might have to install it, and we'll do that a little bit later too. You'll see us do that, right? And when you call library, open parenthesis, close parenthesis, and then the package inside it, this will load it up into our memory, and now we are ready. Now we are ready to use any of the functions in that package. For example, this read_excel, bam, it comes from this package, read Excel, right? You'll notice I have a warning message. That is because, shame on me, I don't have the latest version of R. All right, look at that. Hypocrite right here, people. And then there's a whole bunch of other things about it. Current version of a Tibble package, etc., etc. Don't worry about it. Warnings are all right. If you have an error, then we have to work through that. So, again, long story short, you have the table up here. Now, okay? Now, so these functions happen, right? These functions happen, this thing gets loaded. Now, for those of you, here basically I'm showing you guys how to install third-party packages. We're going to do this explicitly, so don't worry about it right now, right? But I want to introduce you to a function called class. All right, this is a new function called class. And this function is very, it's a function to help us identify what kind of data containers we're dealing with. Because when you start dealing with all different kinds of data containers, you might get a little confused as to what's going on, right? Might get confused to what's really going, what type of data container you're working with, right? Unless you're in the current programming session, you might tend to forget. So class really helps out. Or if you're just doing working on somebody else's code, you're probably not sure what's going on. So here's a class function right here, right? If I call class on X, right, it simply just tells me, hey, it's something numeric, right? It doesn't get into too much detail that it's a vector or whatever. It just says numeric. Now, for the first table we downloaded, the bike share, right, the bike sharing data thingy right here. Sorry, I didn't mean to do this too much, but here we go. Right, if I call class on that, there you go, see how it pops in? Notice the results it gives me. It says data.frame. What is a data frame? A data frame is the basic table that comes preloaded or pre-built in R. That was the original table. Data frame, again, is what pandas attempt. You'll notice for my BAP students, we have that terminology data frame in pandas, right? Well, where do you guys think it came from? It came from here, right? So this is the original table, and pandas, ripped off that name. So that's what chapter 1 underscore this particular table, that's what it is. It's a data.frame, meaning it's the most basic table in R. Now let me call class on ch1 underscore bike. What's going on here? Now we get 3 different terminologies. We're getting a table underscore df, a tbl, and a data frame. What does this mean? What this means is this table that we loaded in via an Excel sheet, all right, versus a CSV, is a different kind of table. And yes, there are different kind of tables in R, right? We, again, use data.table, right? I'll get to that in a second. If this data.frame is a Honda, then this particular table, which has these three different characteristics, you'll notice the data frame here as well. What that basically means is that whatever commands, whatever you can do with a data frame, you can do with this kind of table. But there's these additional names there, and that is because this table has additional features. This particular type of data container has additional features that fall into these categories, right? Table TBL underscore DF, TBL. All right. Now, I don't spend any time. Again, the TBL DF that comes from the ReadXL library, right? I don't spend any time teaching you this kind of table. A little bit this table, right? You're going to learn obviously concepts in this table because every table is essentially in this basic form, this table, right? So whatever commands those other tables can do, whatever commands you can do in this table, those other advanced tables can do it, right? I don't teach you this, right? I just show you this because so you know that, hey, there are different kind of table data containers, right, of different variations, of different features and whatnot. And the reason I don't teach you this because this is out of date now, all right? Like I said before, the industry standard is data.table. When that industry standard changes, guess what? I'm going to use whatever the latest thing is. It's just the way it is, people. That's just the way it is. Right? We keep moving, keep moving. Jab, jab, move. Jab, jab, move. All right? So with data table, I'll get to that in a second, but let's go over some basics of data frames. So, and I just do this, by the way, just to make my life a little bit easier. What I'm going to do is I'm going to create a new data frame from the existing one. To do that, right, because chapter 1 underscore bike underscore sharing underscore data, it's a simple data frame. If I want to create a new table, I simply just do bike equals, all right, done. And now bike is a completely different table than chapter 1 underscore bike. They both have the same content, but they're different and unique. And again, my BAP students, this is different in pandas, right? In pandas, this single equals did not mean that you had two different objects. It just meant that the same table had two different names. Not so in R. In R, with basic data frames, when I do bike or whatever equals this table, I now have a completely new table that's independent of this table. Same content, but completely different. All right? If I do, and again, one of the reasons I do this is because it's just easier for me to deal with typing in bike than keep typing in chapter 1 underscore bike shared data. Also, what I like to do is, if I have the memory, right, if the table is not too large, I like making a copy of the original table and then messing around with it. So in case I make any mistakes, I have the original table. You'll see me do that a lot in the labs. Another command I want to show you guys now is str. So if I do str bike, right, what happens? Well, basically what happens is basically like if I were to click the arrow right here, it gives me a nice little summary of the table. All right. It gives me, first of all, what type of table it is. Again, the rows, the columns. It gives me all the column names: date, time, holiday, season, working day, weather, temp, atemp, humidity, wind speed, casual, registered, count. Right? Because remember, in terms of data analysis, guys, step 1 is what? Step 1 is viewing your table. Right? You got to see what table you're dealing with. Right? In this case, it's not too bad of a table. I got my column names, and I also got these next to the table. What are these guys? All right, what does this mean? Let me break this down into R. CHR is character. It basically means anything that's not a number, any kind of alphanumeric, any kind of name, sentence, phrase, words, what have you, whatever that is, right? That's what character CHR is. That's character, right? Integers, all right, my BAP students, you guys remember this? Integers are any numbers that have no decimal place. It does not matter how large the number is, right? As long as it does not have a decimal place, it's an integer. In R, then what's a NUM? That stands for number. I'll give you guys one guess what number is the difference between integer and numbers. That is correct. Numbers have decimal places, right? And again, it does not matter how large or small they are. If you have a number like 5,000, it's an integer. If you have a number like 0.005, that's a NUM, a number. The reason behind this is, my BAP students, that's correct. In the world of computers, numbers with numbers with decimal places take up more memory than numbers that don't have decimal places. This is a freaky computer architecture kind of thing. Any computer engineers in class, you guys will know this in depth and detail. You guys had to learn this, right? This kind of computer data architectures, memory, all that stuff. But anything with a decimal place takes up more memory than anything without a decimal place. All right, pretty cool. And right off the bat, we can make some observations. We have these columns called holiday, working day, season, weather that have integers, right? They're represented by some sort of integer, right? So it looks like they mean something. These numbers mean something. We'll look into that in more detail. We have a temperature column that has some interesting temperatures, 9,999. So from American point of view, America, clearly this is probably not Fahrenheit. Looks like it's some kind of other strange measure, maybe Celsius, which I'm sorry, I don't know why the hell we're doing that here. Celsius in America, we strictly do Fahrenheit. And then we have something called a temp, and this looks like it's a different scale, right? We have humidity. That looks like a different scale. Wind speed, casual, I don't know what that is. Registered, don't know what that is. Count, we don't know what that is, right? So here we go. We're doing some high-level analysis and making some assumptions, making some hypotheses on the data. Not even on the analysis, the analytics of it, but I would say on the metas of it, all right? So that's the str command. Now, here, ladies and gentlemen, for that data, I have the dictionary for the data, right? The date time is an hourly date plus a timestamp. The season means something. So season 1 means spring, 2 means summer, 3 means fall, 4 means winter. Holiday it looks like it's a binary number. Holiday looks like it's a binary number because it says basically whether the day is considered a holiday or not. Working day, whether the day is neither a weekend nor a holiday. Again, looks like another binary number. Weather has another 4 number category. So 1 is clear, few clouds, partly cloudy. So that's nice weather. 2 is misty and cloudy, misty, broken clouds. All right, slightly worse. 3 is light snow, light rain, plus thunderstorms, scattered clouds, light rain, scattered clouds. And 4 is heavy rain, ice pellets, thunderstorms, mist, snow, and fog. So temp, I was right. Temperature is in Celsius. For God's sake, what the hell is Celsius, people? What is Celsius, right? Fahrenheit, please. What is a temp? A temp, it feels like temperature. So that's what that makes. That's why these numbers are different. So maybe it's just temperature, but it feels like that. And again, I have no idea what that means to me. Humidity, relative humidity, wind speed. Excellent. So casual is number of non-registered user rentals initiated. Whatever that means. I guess it's some sort of rental stuff. Registered is number of registered user rentals initiated. Count is number of total rentals. So apparently there's some rental data information here about some sort of product, right? Okay, probably the bikes, since the name of the table is bikes after all. All right, now let's start playing. And before we can start playing, let's get our table into a data.table. We want to convert it into a data.table, which is obviously a more powerful structure in R. If data frames are Hondas and those TBL_DF table structures from Excel that we downloaded are Beamers, then your data.tables, ladies and gentlemen, that's a Porsche. All right, that's a Porsche until that gets replaced, right? So the first thing you guys have to do is data.table is a library that's not pre-installed in R. Okay? It's not pre-installed down here in R. It's in my machine because obviously I use it all the time, but it's not in your machine. Now, how am I going to install? So how do I install a library or package that I don't currently have? Well, because this is RStudio, it's incredibly easy. All right? It's incredibly easy. Again, bottom right window, 5 tabs. The middle tab is packages. All right, we have that open right here. You're simply going to click on install right here, right beneath the packages. This window pops up, and you're going to type the name of the package you want. Again, this could not be any easier. I'm going to type in data.table. You want to leave everything as is, and yes, you obviously want the dependencies. If there's any other packages that this package is built on, you want that. I click install. All right, and look, this is pretty cool. I have this pre-installed, but it's asking me again. So for me, it's asking, hey, do you want to install from the source packages with need compilation, right? My answer to this is no. I never want to install from anything that wants compilation because that's just more processing power and more work. Just keep it simple. Say no. All right, and then it does all this stuff, and it's done. Now, how do you know if you downloaded data table correctly? Well, if you come down, scroll down here alphabetically, you see the data table should be there. Notice it's not checked. How do we check it? You can literally just check it right here. Right? Literally, you can just check it right there. But I'm going to show you something that's a little more automated. This makes life a little bit easier. If you just use, again, the library command, and then the table, the package that you want to load it into the memory, boom. So I didn't have any problems, but notice I had a warning message. Again, they're ratting me out because I don't have the latest R. Again, shame on me. Shame on me. And now, if you go back to that table, scroll over here, right? If you go back here, you'll notice data.table is now checked. It's now loaded into my memory. All right. If you're at this point, fantastic. If you have an error, probably should shoot me an email or talk to me during the Q&A session at this point for downloading. But for the rest of you guys, I think you're good to go. All right. Now, so I installed it from my packages, called it, it's loaded up. All right. There's my command. Now, I have library.datatable, right? But like before, I have bike, right? Bike is a data frame. So how do I convert it into a data table now, right? How do I do this complex task? Well, it's actually quite simple. If you do set dt, and by the way, as I write these commands, notice that your pop-down fills in, right? All these commands are coming from data table now, all right? So when you load it into memory, all the possible commands there are now also in the drop-down. This set dt command, I'm going to put bike in here. I'm going to call it, bam. It's that simple. I'm done. Now if I do class right here, again, remember the class command. The class command, what does the class command do again, guys? That's right. It tells you what kind of data container you're dealing with. If I type class bike, looky what it says. It now says data.table and data frame. All right? Data.table and data frame. That's how easy it is to convert a normal table into a data table. And look how fast it was done. Now, obviously, the bike table is really small, so it was fast. You know, it's obviously not going to take that much memory, but it's that pretty much easy. Now, hypothetically, let's say for some reason or another, you want to convert a data table back into a data frame. Oh God, how do you do this? Very easy. There's another command, set df, right? That will take a data table and convert it back into a simple data frame, basically going from Superman back to Clark Kent, right? And now if I run class bike on that, as you can see, it's now a data frame, back to a normal data frame. I obviously want the data table, so I'm going to rerun line 12 and confirm that it's back to data table, and now I'm ready to rock. All right, I'm ready to rock. All right, so now we are dealing with the data tables. And now I'm going to show you how to use data tables. All right, I'm going to show you the power of data tables, guys. And for my BAP students, you might dig the simplicity here. You might dig the simplicity of the data tables versus the pandas tables. I mean, I would say both are simple in their own way, right? But they just have their own syntaxes. But I mean, it depends. It's up to you which syntax you feel more natural with. This syntax feels more natural to me than Pandas. But again, vice versa, it doesn't matter, right?